Most likely, your data center architecture has been built off of a three-tier model, which encompasses a core for high-speed switching, an aggregation for policy-based connectivity, and an access layer for local and remote workgroup access. The core layer is a high-speed backbone that is designed to switch packets as fast as possible. Because the core layer is critical for connectivity, it's got to be very highly available. A lot of times it's comprised of modular-based switches that have a very high mean time between failure. The core layer also provides scalability and fast convergence. Next down from the core layer, we have what we call an aggregation layer. And the aggregation layer is what takes multiple racks of servers or multiple rows of server and aggregates those connections all in one place. We use the aggregation layer to isolate network problems so that if we have a problem in a single rack of network equipment, it doesn't affect the rest of the network. We also try to incorporate services at this layer. Because it's the aggregation layer and the server traffic has to pass through that layer, it makes for a common area for us to be able to insert services like firewalling or IDS or IPS and get the most bang for our buck. You may be familiar with this in the campus environment where we use the aggregation layer in a similar way, a lot of times to bring edge campus connections or closets to a single location before we bring them into the core. This aggregation layer allows us to very easily add more server racks and scale out very easily as long as we have ports available in our aggregation layer. The access layer is all about granting access to network devices. This is where we want high-speed, non-blocking connectivity for our servers to access your environment. In the data center, this is what provides access to your servers, your mainframes, your backup devices, and your virtualized environment. This layer can also provide IP-based access for storage devices as well. So once again, in the data center, the access layer provides connectivity for servers. This would be an example of a traditional three-tier architecture. As you can see, I have my data center core layer, which in this case is running on the Nexus 9500 series platform. It also could be the Nexus 7000 series platform, two very common models to use in this type of environment, as well as the fact that I have an aggregation layer that allows me to consolidate all of the access layer coming up into that tier. That platform as well could either be a Nexus 9000, 7000, or in the past could even be a 5000 or a 6000. At the access layer, I sometimes will use what we call fixed configuration switches because I may only need 2 of them at the top of the rack, so I don't need that many ports to plug into, but I still want high-speed connectivity. And in that case, I can use any combination of a Nexus 9000 with a fixed configuration layout or a Nexus 5000, or in some cases even a Nexus 6000 in the center of the row, and then run the cables from the servers to the center of the rack where that modular switch with all the ports resides. In any case, this is a good example of what a three-tier topology looks like and what you might find in a common data center. Please join me for the next lesson, 4.3, Understanding Two-Tier Architectures.